Well, here it is, my 3G, low, medium, high-res, Bally, Astrovision, Astrocade, take your pick, home computer. It's my third generation modified for high-res console. My first generation console utilized dynamic RAM and had an add-under screen RAM board. There were 32 chips of DRAM. My second generation console utilized static RAM and also had an add-under screen RAM board. There were only 4 chips of SRAM. This third generation console has all the necessary electronics inside the console to generate the low, medium, and high-res graphic modes. There is no add-under board. Only 4 screen RAM chips are used. You can see the standard motherboard power transformer and the 3.5mm to RCA composite video and audio connector cable. Behind the console you can see the quick connector for the remote plus 5V DC power supply. Okay, I'm going to remove the 5 screws on the console bottom and remove the console top so we can take a peek at the motherboard. The RF modulator is piggybacked with the composite video and audio circuitry. This modulator is likely a first generation modulator, so it's about 45 years old. It outputs a terrible, very dirty TV display. The 8-pin connector to the RF modulator has no ground line. This Astrocade has no bottom RF shielding to ground the modulator, so I ran a soldered ground line to the 6.8 microfarad electrolytic capacitor designated C8 to the modulator. Here's that ground line connected to the capacitor. It runs to the breadboard, then back to the RF modulator. I'm not going to remove the cartridge slot keypad assembly from the motherboard on this video. The 3G Astrocade is well documented, including photos on the Atari Age Astrocade subforum. There is a link to that Astrocade homepage in this video's video description. The double-stacked screen RAM circuit boards are underneath the keypad. There is another circuit board underneath the cartridge slot. The 27 ohm 1 watt power resistor R1 is now resting in front of the motherboard to make room for the double-stacked screen RAM boards. Here's that 27 ohm power resistor. It's no longer located on top of the motherboard where it normally rests, but now it's located in front of it. You can also see the interconnecting wiring to the 2 double-stacked boards. You might be able to make out the bottom of the 2 double-stacked boards, and there's interconnection between the 2 stacked boards right here using multicolored number 30 wrapping wire. The composite video driver is generated by a simplistic electronic scheme centered around the THS-7314 SMD chip. The video display is very clean and clear. The colors match the colors seen on the RF modulated video display. The audio line is merely an electrolytic coupling capacitor. What really increases the TV display clarity is replacing the factory video line 3.3K resistor designated R33 with a 1K ohm resistor. Here's that 1K ohm resistor located right here. The yellow video and green audio outputs are wired to a 3.5mm stereo jack. Note the 2 lines are only number 30 wrapping wire. My composite video and audio driver schemes are documented on the Atari Age Astrocade subforum. The posting is entitled MCM Designs composite video and audio upgrade. I adjusted my TV display's parameters to my preference. Because the Astrocade's power transformer is symmetrical, it doesn't matter which way you plug in its 4-wire brown connector to the motherboard. You can plug in that brown connector to the motherboard either this way or that way, which is the way I prefer because you can see the contacts making contact with the input line connector. The custom data chip on this motherboard only uses a cheap poor man's heatsink. Here it is, Astrocade's deluxe heatsink. Regular heatsink compound is used, not thermal glued. Heatsink compound becomes tacky enough to hold the heatsink in place. You do not have to glue a heatsink to this chip. I use a small 4-inch fan as forced air cooling over the data chip and voltage regulators. This is an attempt to not only preserve their lifespan, but extend their lifespan. The chip and regulators operate warm, not hot. I can actually hold my finger down on top of the data chip and my finger will not burn. Astrocade users can place a 40-pin DIL heatsink on top of the factory thermal-glued heatsink if their Astrocade does not implement the latter factory heatsink upgrade. Remember this, do not attempt to pry off the poor man's data chip heatsink. The chip's plastic package is very fragile. If you try to pry it off that heatsink, you will likely crack the chip. Don't take the chance. In this video clip, you can see the entire SRAM control lines board. This board is elevated using nylon screws and hex nuts. It's held in place on top of the motherboard by grounding 2 bare ground wires to motherboard ground pads. The first ground wire is soldered here to this pad. The second pad is down here, you can't see it, but the ground wire here is soldered to that pad. The board receives and generates a couple clocks and the necessary SRAM control lines. Interconnecting input wires come in from the bottom right through an existing motherboard hole. The input wires are signal taps coming from the bottom of the motherboard. Output lines exit at the top of the output header, most of which are routed to an input header on the bottom SRAM board. There is only one chip on this motherboard that is not in a socket. The additional sockets on this motherboard were installed courtesy of Alan Schweitzer of Gambits. Thanks, Alan. A peculiarity on this motherboard is a previous owner thermoglued a 40-pin DIL heatsink onto the custom I/O chip. Why? This Astrocade was generating intermittent noise on the audio output line. When I pushed down on that heatsink, the noise quit. I used a 400 grit wet dry sandpaper to clean both sides of all the 40 I/O chip pins. The noise quit permanently. Apparently the chip had some dirty pins. That's it for a tour of the 3G Astrocade. I'm nearly ready to power on my 3G low, medium, high-res Astrocade. You are looking at my 2G BalcheckHR board, which I will plug into the back of my 3G Astrocade as part of my test setup. This multi-carded board is packed with low and high-res diagnostics, plus low and high-res graphic test demos. It features 2 powerful diagnostics called Z80 Check and Balcheck, sometimes called BalcheckHR. This BalcheckHR is an upgrade of the factory 2KB BalcheckHR. The dual 7-segment display is decoded to display hexadecimal numbers, making error sequences and other info easier to read compared to the factory version. Alan Schweitzer owns the 1G BalcheckHR board. This diagnostic board is documented on the BalcheckHR.com website in the BalcheckHR section. It's time to set up this 3G Astrocade and run some low, medium, and high-res graphic demos. Finally. It's time to run this 3G low, medium, high-res Astrocade to demonstrate what it can do. My BalcheckHR board is plugged in back of the Astrocade, positioned vertically so you can see the dual digit display. I'm going to run a bunch of graphic demos. I'll run each demo about 30 to 45 seconds long so you'll get a good look at all kinds of graphics to experience just how well this modified Astrocade performs. Here's the stored demo. Coming up is the factory Balcheck, testing low-res screen RAM, among other things, for errors. You will see Balcheck run 4 test passes, outputting audio after each pass. After the 4th pass, the dual display will indicate E1, which means no errors were found. I'll run Balcheck again. Watch the dual display behind the Astrocade. Watch it initialize to -- count up, then display E1. Here's my checkmate variation. It's a great test demo. It runs 100 rounds non-stop. There is no pizza break. Here's the fish demo. This is another great low-res demo to check for operation perfection. It magic exclusive OR writes plus exclusive OR blanks 10 fish. It has an elapsed time display to tell you how long the demo has been running. You can also change the water to light blue. Here's my test pattern variation. There are 3 test patterns. The initial test pattern was created by bit fiddlers. Here's my BalcheckHR title page. Two screen interrupts were used to display the blue and black horizontal colors across the entire TV display. The BalcheckHR text string gradually changes colors. My final low-res graphic test is Treasure Cove. The title screen is so cool. That's it for low-res graphic test demos. Up next is the medium-res graphic mode. I only have 2 demos for the medium-res mode at this time. The second demo will give you a good feel of comparison between the 3 graphic modes. It's very likely that since this video has been released, it's been nearly 45 years since anyone has seen this home computer system run in a medium-res graphic mode. High-res, medium-res, low-res. The high-res graphic mode has the smallest pixels. In medium res, the pixels are twice as wide as high-res pixels, but have the same height. Low-res pixels are twice as wide and twice as high as high-res pixels. High-res, smallest pixels. Medium res, in between, twice as wide as high-res pixels. Low-res has the largest of the 3 graphic modes. This second medium-res demo compares text character strings with each graphic mode. The high-res and medium-res strings use 7x9 pixel characters. The low-res strings use 5x7 characters. The low-res characters look crude compared to the more detailed high and medium-res characters. Low-res has the smaller 5x7, but larger pixels. Characters look pretty crude compared to the other 2 graphic modes. High-res has the smallest pixels, provided the most detail. 7x9 pixels in this test demo. Medium res. Now the pixels are twice as wide. Quite a distinction between high res and medium res, eh? That's it for my medium res test demos. Next is high res. Remember the low-res test called BalCheck I showed you a little while ago? Here it is. Here's the high-res screen RAM test. This test is similar to the 4K byte low-res Balcheck test, but checks the entire 16 KB high-res screen RAM for any errors. Each high-res pass requires more time to test. A completed pass is indicated on the dual-digit display as an increment in count. Testing will continue non-stop unless a data error is found, in which case an error sequence is displayed on the dual-digit display showing which of the 4 high-res banks are in error. The dual display is now showing that 2 test passes have been made. The high-res test pattern variations here will show 4 vertical bars with texture. The perimeter around the test patterns will also display texture. This original high-res test demo created in the mid-1980s is an excellent test for high-res graphic perfection because of the multiple static graphics written with various magic functions plus 9 graphic patterns moving around the TV display. There is even an elapsed timer to tell you how long the program has been running. The pixel stringer continues to write a long string non-stop at a very fast speed. Each show variation lasts nearly 20 seconds. The next high-res test demo is a variation of my multi-pager graphics program. It will quickly write 8 pages of graphics, ending with a highly detailed gunfight graphics variation. Note the detailing in this high-res gunfight screenshot. Here's a highly detailed fish demo moving 12 fish around the TV display. Magic exclusive OR writes, blanks were used. A screen interrupt is used to generate an additional 3 colors, totaling 7 colors for this test demo. This graphic test demo was created when I was developing my 2G high-res Astrocade, which uses static RAM, SRAM, instead of dynamic RAM, DRAM. This is what I call a write-only graphics program. No Z80 stack area was used. No subroutines were utilized. The Z80 only wrote bytes to screen RAM. No screen RAM addresses were read by the Z80 CPU. Here's a small portion of the ultimate Astrocade without the soundtrack. Introducing the Ultimate Astrocade, modified to display lower high-res graphics, upgraded with user RAM and custom high-res graphic boards. It certainly has a lot of goodies. This is my high-res MLM, Machine Language Manager, which is an upgrade of BitFiddler's low-res MLM. The background color is light blue with black text characters and a white cursor, which my Canon camera has difficulty capturing correctly. One of its commands is a list command. For example, I can list machine coding within the low-res ROM beginning at 0000 hex. As this video has shown you, my 3G low, medium, high-res Astrocade functions great. There are two distinctions between this 3G low, medium, high-res Astrocade and Perkins Engineering's version. The 3G Astrocade displays low-res with a full screen display. Perkins' low-res display was only in the upper left quadrant. The 3G upgrade wiring is very tidy. Perkins' version wasn't too tidy. Maybe this video will inspire someone with a modern technology expertise to design a drop-in motherboard replacement or something else for the Astrocade, providing low, medium, high-res graphic modes. MCM Design has laid down the foundation for that possibility.